early February of this year, researchers of the National Ignition Facility, or NIF, at the Lawrence Livermore National Laboratory in California have announced a milestone breakthrough in the search for clean and efficient energy.
In a paper published in the scientific journal Nature, the scientists revealed that in a historical first, their efforts in the field of nuclear fusion have yielded more energy than was initially put into the hydrogen particles that act as fuel. Nuclear fusion is what powers the stars of the universe, including our own sun. It is a phenomenon in physics where four light hydrogen atoms fuse together to form one heavier helium atom, which releases energy in the process. It is a highly promising source of clean energy. Fusion reactors would run on a common form of hydrogen found in seawater, would emit minimal nuclear waste, and couldn't have the kind of meltdown that can occur in a traditional nuclear fission reactor. What makes it even more interesting is that nuclear fusion sustains itself once it reaches a critical point, called ignition, without needing additional energy. The fusion achieved at the National Ignition Facility comes from a hydrogen isotope fuel cell heated by energy from 192 lasers worth 1 trillion watts. The 170 microgram fuel cell heats up to temperatures hotter than the sun and implodes at several hundreds of kilometers a second, creating the conditions necessary for hydrogen fusion. With this process, the researchers of the NIF have managed to create stable fusion that yielded more power than the fuel cell absorbed. However, the facility's efficiency is not yet optimal, as 99% of the laser's energy was lost before being absorbed by the hydrogen isotopes, meaning that the facility technically still uses 100 times more energy than it produces. Despite that, the hydrogen cell produces more energy than the 1% it did absorb, which is a landmark achievement. Now, the focus for researchers lies on improving the efficiency of the energy absorption and increasing the power and yield without compromising on stability.
With that, the NIF is once again exploring the unknown, but if this achievement is anything to go by, we can be sure that the National Ignition Facility in Livermore, California will surprise us once again. For SciTech PR, I am Nicola Quentebach. Thank you for watching.